Hi guys, so today we'll be doing the minimum operation task. It's just a task and it's a very quite interesting and simple task. So the project or the task goes this way. It says that we should write the minimum way in which we're going to, it said in a text file there's a single character each. So we have a file. So let's say we have a file and the file contain each. So let me see, I think I have this. So let me just make a directory here and say test and cd into test. Okay, so we have a file. So we have a file, and if we cut the file, it contains h, right? So it says that your editor can execute only two commands in this file. So we can either copy all, so we can either copy that h that is inside this file. Okay, so it's either we copy the h or we paste it. So we can either do, let's just say our copy is echo h into file, right? So it's either, no, we copy it. Copy is like just get the object h, and then we can paste that h, that is we can then echo it into that file. Okay, so we can do those two things. And it said write given a number n, so if we are given a number, let's say 5, write a method that calculates the fewest number of operation needed to result in exactly that 5h in the file. So how many copy and paste do we need to do? So for example, we are given 9. Okay, so if you check the math behind this, the solution behind this is that you need to get the prime factorization. I think there's a prime factorization video. This video will actually help you if you watch it. So this is prime factorization, and the prime factorization of a given number will give us the minimum operation to perform this task. For example, what is the prime factorization of 9? Prime factorization is, what is prime number? Prime numbers are numbers that can divide itself and can be divided by 1, right? Only. So the prime factorization of 9 is 3 and 3, because 3 is a prime number and 3 is a prime number. So it has to be both prime numbers. So we have 3 and 3, and if you add the sum of those prime number is the answer. So if you see 9, it is 3 and 3, which is the sum, which is 6. And if we see for example, I think we're giving in this test for 4 is 2 and 2. 2 and 2 is what? The addition 4. For 12, if we do the prime factorization of 12, we'll have 2, which would remain 6. We'll then have 2 again, which will remain 3, and then we'll have 3. So if we have 2, 2, 3, we'll have 2 plus 2, 4, 4 plus 3, 7. So that's basically the maths behind it. And if we look at for 9, what did they do? The file contained h already, and we need to, okay, it is 3 and 3, so we need to just find a way to make it up to 3, and then just copy and paste that 3, make it a 6. Okay, then copy and paste that 3 twice, right, making it a 9 rather. So what they did is we first copy that h, because we can't just paste what we don't have. So we copy it, that's one operation. Then we'll paste it inside the file, then making it 2. Then we'll paste it again, because we need to get to 9. If we copy this one, we might not get to 9. Okay, so we paste that single h again, then it's 3. Since we have 3 again, we can just copy all and paste twice. So copy all, because this is 3, and paste, giving us 6, and paste again, giving us 9. Okay, if we count the operations that we did, 1, 2, and then 3, and then 4, and then 5, and then 6, and that's it. So let's go back to our task and see. I've already, like, I did this video, but I figured out the recording wasn't okay, so I just have to re-explain this. So minimum operation. So what was done, as you can see, is a very short code. We have shebang line and then function definition. So the first thing you want to do is, if the n number that is coming in, right, if it is 1, for example, it means the file already has that 1h, right? So it's going to return 0 because you don't need to do anything again. You don't need to copy, you don't need to paste, it's already there. And if it is less than 1 also, it means that you are not doing anything, right? Good. So we come here and then we say, okay, how many operations do we need to take? Let's just say it is still 0 for now, right? Then, because we need to add the sum of prime numbers, the best way to start dividing a number to see if it's a prime is using 2, right? So we first say, okay, we want to use a divisor, which is 2, and then that's it. We keep that as well. So we say, while that number, as far as the number, we need to find a way to divide the number by 2, and if it can be divided by 2, we go to 3, go to 4, go to 5 until we have 0, right? So until we have 0, and the only way we have 0 is when, if this is 0, 0 is not greater than 1, then this loop will stop, right? Good. So what we do is we say, while that number is still greater than 1, we still need to be trying to get the prime numbers, or trying to get what can divide it. That will be a prime number. Okay. So while that, then we have another while and say, while that number divided by the divisor, which is 2, if it gives us 0, that is, if it is divisible by 2, which is our minimum prime number, then the operation will add that 2 to it, and then we have to subtract or divide that 2 by that divisor. So if it is 8, for example, then we'll say 8 divided by 2, will it give us the remainder? Will it be 0? Yes. If it is, then we'll add that 2 to the operation and then divide that 8 by that 2. We use this double slash showing that it's an integer division. So in that sense, it becomes 4, right? So it becomes 4, and then this loop goes again, right? So if peradventure we had 3, right, and it can't, maybe the remainder is 3 and it can be divided by 2 to give us 0, then the divisor would be incremented by 1, showing that, okay, let us try to divide it by 3, right? So by that time it works, and then probably we get 0, and when we get 0, right, when we get 0, it will run out of this loop. Okay, this 0, it will run out of this loop. But once it's still not 0, let's say it is 5, for example, and we try to divide it by 2, it didn't work. We increase the divisor, try to divide it by 3, it didn't work. We'll keep on going until we get to 5, and then until we get to 0, then it's outside this loop, and then it will return the addition of all the prime numbers. We just need to get the addition of all the prime numbers. That's the operation, the amount of operation we need to do. And if you have any question, let me know. So see you in the next one.